In this video, I'm going to be talking about measurements. In life, we measure a lot of things. We measure things like distance, time, temperature, we measure weight, we measure speed, we measure a lot of things. And in event planning, measurements are very important. When you work in the event planning industry, it doesn't matter whether you're a cleaner, a driver, or a salesperson, you need to master this thing called measurements. Okay, since there are a lot of things we measure in event planning, we just want to focus on few things that we believe they are more important. Few types of measurement, and this type of measurements are let me see. All right, this type of measurement are, let's say, length. We have length. Okay, it's very important to know about length, to know about area, the area of something, the volume of something, and to some extent mass, which is weight, the weight of something, the weight of something. All right, so now that we are talking about all these things, let's talk about length. All right, what is length? Length is the distance between 2 points. All right, it's very important to know what length is. All right, so here, for example, let's say this line here. This line here can mean anything. All right, it can mean the distance between Banjul and Brikama. Okay, it can mean what? It can mean the height of a person. Sorry, the height of a person. All right, it can mean the height of a what? Skyscraper. Okay, it can mean the length of my let's say my hand. This is my shoulder. This is my hand. All right, this is, so it can mean the length of a pencil. All right, so length can mean anything. Okay, how long something, length measure how long something is. And in life, many objects have different, an object has different lengths. All right, like if you look at this tissue paper here, it has different lengths. All right, first of all, it has a length here. All right, a length here, it has a height here, and it has a width here. Like from here to here is a width. All right, a lot of things. All right, like this cylinder here, you have the circular base here. This circle has a circumference here, it has a diameter, it has a radius. All these type of things are length. All right, so here, for example, all right, so for here, like if you look at this box, here, it has length here, it has height here, it has width here. All right, note that all these things are called length. All right, we just differentiate it so that human beings, we like to make things different so that we can be able to differentiate it. But this height here, consider it as a length because it's talking about from point A to point B, how long this point is. And also the width here is a length because it's talking about how long this side to this side is. That's why in this video, I in this picture here, I made it. This is length, this is length, this is length. All right, so we just differentiate them. Different objects have different length, as I told you. Okay, like for example, a circle, you have this length here. All right, this curve here turns into a length. All right, this side to this side is a length. And in circle, what do we call this length? This length here, what do we call it? This length, we call it the circumference. Circumference or perimeter. Perimeter. Okay, mostly perimeter, we use it in squares and rectangles, but the circumference is this. All right, and from the center of the circle to any point in the circumference is called the radius. All right, this radius here is also a length. You can call it a length because it is from one point to another. All right, and you also have diameter as well. Diameter is from any point of the circumference to any opposite point is a diameter. All right, this diameter here, you can see it is a length. All right, like for example, these days we recently bought over 50 round tables. Round tables, they are round, circular, and we bought this time we bought the 150 centimeter diameter. Like from here to here is 150 centimeters. All right. Last year we bought the 180 diameter. Those ones are very big. You know, they don't fit inside the panes. So that's why this year so when buying tables, for example, we tell them diameters. All right. So every time there's something important that you measure. Like for example, if you look at me, most of the time you look when you want to measure something, you measure, let's say, the height, the weight. You don't measure things like my volume. Okay. So every time there are things that are important to measure, and there are different sides of different things. Like other shapes, let's say for things like triangle. Yeah. Triangle, okay, it has a length here, a length here, a length here, and these lengths are called differently. All right, you see this side, this one is called the sides, S sides. All right, this length here from here to here is called the what? It's called the base. All right, remember, everything is length. As long as it is talking from one point to another, it becomes length. All right, and in life also we have to know that not all shapes are regular shapes. We have, although we have this parallelograms wherein two opposite sides are equal, and we have perfect circles, and we have perfect triangles. This is just to make our life simpler, but in life you realize that, and you have perfect lengths like this. Let's say the distance between Banjul and Brikama, it's not like this. Okay, it is something like this, but we just make it like this to make it like simpler. All right, we just connect this dot here, we just connect this dot here, and make it like this, and say this is 30 kilometers, something like that. All right, and you can have, let's say, when you want to buy a piece of land. Okay, when you want to buy a piece of land, it's not like the land is like this perfect piece of land and they tell you it's 20 by, let's say, 20 by 15 meters. All right, most of the time the lands are like this. All right, so what we do is we just like make it such that it is square in shape, so that life will be easy for us. Like there is nothing like in real life where you have a perfect circle, but we just make it like that so that life will become easy with us. Now that we understand what length is, length can mean different things. Okay, all right. When you look at this photo here, all right, remember the height here can be called thickness in certain objects, because certain objects, their height does not make sense. Like a SIM card. A SIM card is so flat that its height almost doesn't make any sense. All right, like this tape line here, this is the height. So this height here is like the thickness. All right, so certain times you can substitute the word height with thickness, and sometimes some people use breadth, okay, instead of width. So that's why when you see these formulas, when somebody is saying length times breadth times height, so this breadth can easily mean what? Width. All right, so when you see them in certain formulas or certain calculation, just know that they are talking about the same thing. All right, now that we know what a length is, let's talk about what area is. All right, and let's open it by this statement here that says, all right, okay, suppose someone tells you they are selling a 30-meter land at Brusubi, phase 1, along the Bruford Highway, opposite the GT Bank, for $10 million. All right, so here you have, you know the information. All right, you know that they are selling let me change the pen. All right, so you know that they are selling a land, a 30-meter land, okay, at Brusubi, okay, near probably the highway, the Bruford Highway, and they are selling it for how much? The 10 million. All right, so you know this information. Okay, this land here is 30-meter long. All right, it's 30-meter long. All right, but something is missing here. All right, something is missing here. What is missing? All right, you know how long, but how wide it is? How wide is it? All right, because in order to determine the size of a land, you need to know at least two sides, so that you can know. So if they tell you it's 30 meters, you need to ask them, okay, how wide it is, all right? Then they'll tell you it's 30 by, let's say, 20, all right? 20 meters, 30 meters by 20 meters, all right? Now you can be able to determine the area of the land. All right, now you can be able to do that. This 30 can be anything. It could have been 30 by 10, then you will have say, no, this 10 million is not worth it. Or it could have been like 30 by 30, and you're like, woo, this is like crazy, it's good, let me buy it. All right, maybe you are a semester, you want to buy that. So I'm just telling you that area, where area comes in, is when you multiply two lengths together. All right, area means multiplying two lengths together. When you have a square here, all right, remember square, two sides, length. This length we decide to call it width or height, whatever. All right, so we call length times width gives you what? Area of this place. Okay, so area is the how big something is on the surface or on one side. All right, let's say for example, you remember length means, when we talk about length, we mean length is the distance, let's say, between here and here and here. All right, this distance here is the length. All right, this distance here is also a length. From here to here is also a length. All right, and also from here to here it's also a length. This length we call it the height, whatever. All right, now you want to know how big this thing is on the surface. Maybe this entire space, how big it is. All right, or this entire space, how big it is. All right, or this entire space, you know, it has different sides. All right, what is the area of this side here? All right, you say length here times maybe height or width, whichever two sides you get, because both they are equal and opposite. This side is equal and opposite, this side and equal and opposite. So it's a perfect rectangle. All right, so you say this times this, you get the area of this side. If you want to know the area of this side, what do? You say this length times one of this length, and then you get the area of this side. So area is the multiplication of two lengths together. You have area. All right, so let's say this land, for example, if you want to know the area of this land here, this land is a 5,000 square meter land. It's probably the size of a football field. All right, because the length is what this is like a rectangle shape, you know, this is like a perfect rectangle shape. All right, so you have this side here is 100 meters and this side is 50 meters. That's why you have 50 by 100 meter land. All right, coming back here, you realize that, all right, coming back to this 50, okay, 50 by 100 meter line, this gives you what? An area of 5,000 square meters. So notice here, we are not only using meters, because this is meter one length, this is meter one length, but here we are having square meters, which means that we are combining two different lengths together. That's why in area, wherever you see square meters, know that it is talking about what? Area. Okay, square meters is about area. All right, remember in length you only have one dimensional x, linear x, meaning that, you know, there is nothing like x square or whatever. It's just linear, one dimension, here to here or here to here. But in area you have what? Two dimension, because you are combining two lines together or two distances together to have an area. Also, one thing you will notice that in real life, people will not tell you, I have a 20 square meter land. If somebody tells you that, you know, probably they are like confusing you, or, you know, most people don't like square meter. So we just leave it like that. All right. A 5,000 square meter land, this 5,000 square meter, we just leave it by 50 by 100. Okay. We say 50, I have a 50 by 100 meter land at, let's say, Viringara or somewhere else. This means that everybody will know that one side is 50 and another side is 100. But when you say 500 square meter land, this 500 square meter, first of all, it is confusing. Secondly, you will not know which side is how much and which side is how much. Okay, when you have this thing, this 500 square meter land can mean anything. It can mean probably, because the square root of 5,000 is probably 70. 70.7, something like that. All right. So this could have easily mean 70.7 and 70.7. All right. Like there are a lot of, especially when it comes to tens. All right. Especially when it comes to tens. All right. You can have, let's say, a 6 by 9 meter 10. All right. 6 by 9 meter 10. What is it? It's like this. 6 by 9 meter 10. It's like 6 by 9. All right. So this side is 6. This side, you can easily say I have a 54 square meter 10. 54 square meter 10. 54 square meter tent. All right. But when you say I have 54 square meter tent, it's somehow a little bit confusion. All right. Because you don't know which side is which side is which. All right. Let's get to another example which has a more easier multiple. All right. Let's say a 6 by 3 by 6, 3 by 6 tent. All right. 3 by 6 tent. A 3 by 6 is like this, 3 by 6. All right. This is 18 square meters. All right. When you see it, when I tell you I have an 18 square meter tent, okay, you don't know which side is which. This could have easily been what? This could have easily been, okay, a 2 by 9 meter tent, a 2 by 9 meter tent, which is also equals to 18 square meter. So the reason why most of the time you see the term square meter, you see the term something by something, you know, x by y, it means that this side is this side is that. They are combining two lengths together to form an area, and we leave it like so. When we are mentioning tens and other things, we just say that, you know, it's 3 by 3, 3 by 6, 4 by thing. Know that it is like it's talking about this side is this side is that. And also we always start with the smaller side. All right. Although you can start with any side, because here if you say 3 by 6 is the same as 6 by 3. All right. It's just like flipping it, but it's all the same. But the norm is you start with the smaller side, which is the width, and then you go with the length, all right, to the bigger side. All right. So now that we know what length is one dimensional. All right. Length is one dimensional. All right. Area is what? Two dimensional, like this and this. And now let's talk about volume. All right. What is volume? What is volume? Okay, in volume you are considering three sides. All right, remember in length you are considering one dimension. All right, in area you are considering two dimension. All right, remember we are talking about, let's say, this tissue paper. All right, in length we have this this in area, let's say the area of this side only, where they like the Adora, this side only. Okay, you see, that's, let's say, that's the corresponding side, you see. But imagine if you want to calculate the size of the whole box, this tissue paper box. Okay, let's say this tissue paper box, let me like draw it like this. All right, let's have this, let's have this, let's have this, let's have this. Okay, now we are talking about volume, because now we have this side. All right, now we have, okay, now we have this side here, and we have this side here, which is the height, and this side here, which is the length. All right, now we have length. All right, length times, okay, width. This is the width, this is the height. All right, this is the length. Length times width. Some people will say length times breadth is all the same, times height. Remember, all these things are lengths, you know, but you know, we just differentiate them so that we can know which each side is. So now we have volume. You remember, area you are multiplying two lengths together, but volume you have three lengths together. That's why volume is x cubed, cubic meters, or cubic centimeters, or cubic feet. Why? Because you are multiplying three lengths together. All right. So yeah, it is like when we talk about volume. All right, you see, volume is the total space taken up by an object, the total space. All right, when you are talking about how big this thing is, okay, so sometimes you want to know how big this thing is to know what you can fit in there. All right, remember, when it comes to area, you are only talking about, let's say, this side only, or this side only, the area of this side only, or this side only. All right, but now we are talking about the area of the entire, let's say, this cylinder, you know, so that you can know probably the amount of beans you can put in there. The same thing with bottles, all right? As they say, the bottle of water. The bottle of water. This is the bottle of water. All right, you have this side here. You see, this is the area of on the surface here. All right, but you also have the height now. Now, if we consider the height, now we are talking about volume. All right, and volume of liquid is mostly in liters. This thing you will see it is like 500 milliliters. Okay, 500 milliliters. Where is, yeah, it's here, 500 milliliters, right? 500 milliliters or 0.5 liters. So they are different ones. So let me talk about them here so that you can see application of length, area, and volume. Okay, it is important to note that there are situations where we consider only length or only area or only volume. Okay, how do we know when to consider which? All right. So situations where we consider length, all right, where we say, hey, here we want to know the length, that's all, we don't want to know the area. Okay, situations like distances between places. Let's say the distance between Banjul and Brikama. Okay, you don't want to know the area, this area. You don't want to know like the area it covers. You don't want to know the height, because you know the height one can only go so high. All right, so you don't want to you only want to consider one distance, which is one dimension, which is the length. All right, the length. All right, so you know, and that's why I say, you know, most dimensions are not perfect. You see, which is like, you know, 30 kilometers roughly. Okay, some places where also you consider one dimension only is the height of a person. When you want to know how tall someone is, you choose, you say, I only want to know the length. All right, or a race track. All right, you want to know, okay, what is a 100-meter race like? Only the length. You don't want to know how big something is, you know, because you are going to run 100 meters. You know, there are a lot of applications wherein you only need to know the height. Let's say when you are talking about tall buildings like the Burj Khalifa, for example, you want to know, you know, how big, how long is the Burj Khalifa? Probably it's 900, you know, meters. Right? You don't want to know how big it is or how beautiful it is. For example, you just want to see how now many countries are competing for who can get taller. I think in Saudi Arabia they are building one which is going to be taller than the tallest building right now. So this area's length matters. All right. So where those area really matters. All right. So for example, when determining the size of a parcel of land, we only want to know the area. All right. We don't want to know the volume. Let's say when you want to go and buy an empty land, you don't want to know the volume. You don't want to know the length, one length, because knowing one, remember the example I gave you, knowing one length only will not help you. You need to know another side when determining the area of something, at least two sides when determining the area of something. All right, so let's say here I say there, who cares about the height and volume of an empty land? Okay, of an empty land or space, the sky is the limit. All right, so that's why when you look at here, for example, this land here, when you look at this land here, when you want to find the size of a land, you don't want to know about, let's say, only one dimension, because if you know that this line is from here to here, yes, but how big it is, you want to know at least, maybe you will have stopped here and it's a bit like this, then you like, this is not that big. But when it goes further down here, at least now you know 2 dimensions. This is square land. Okay, perfect square. So that means that this side is equal to this side and this side is equal to this side, and you know, you can just multiply this thing to know this area. All right, so here you don't need to know the height of the land, because nobody's going to tell you are not going to build as high as you want, whatever the height, the sky is the limit, you know. Somewhere, let's say somebody is putting a wallpaper for your wall. All right, they want to know the size of your wall. All right, they want to know this side, let's say to this side is how many, and how many meters, and this side to this side, so that they can know the square meter of your wall, so that they can know how much wallpaper you should buy. Example, carpets as well. For example, when I order, let's say when somebody orders a, let's say a 6 by 12 meter tent, 6 by 12 meter tent. All right, and they tell you they want you to cover the 6 by 12 meter. All right, let's say the 6 by 12 meter tent is okay, let's say the 6 by 12 meter tent is like this, 6 by 12 meter tent. All right, so we have the 6 by 12 meter tent, and this is it, the 6 by 12 meter tent. All right, this is 6 by 12 meter tent, and they say they want carpets. So it's very easy now. What you do is you just say the area of the tent is like this, and the entire thing has to be carpets. All right. So it's very easy. You just say the area of the tent should be the same area of the carpets. So you say it's 72 square meter carpets. It's very easy, right? So you are going to need 72 square meter worth of carpets to cover this distance. So all right, you don't want to know the volume of the tent. You don't want to know you only need to know two sides of the tent so that you can determine how many carpets you can bring. Maybe you are a person who rents out. Okay, maybe you are a person who rents out carpets. All right. So these are applications wherein we use this thing, wherein we use area. All right. So we are a situation where volume matters. Volume. All right. So situations where it is important to know the volume includes the amount of water a bottle or tank. You want to know the amount of water this bottle can carry. If they tell you it's 500 milliliters, then it can carry 500 milliliters of water, okay, or half a liter of water. All right. So you want to know how big, or a water tank. Right now we have a water tank at Jollof Events, and it is like I think 2,000 liters. 2,000 liters. It's as big like this. All right. You see, it's 2,000 liters. So you want to know the size, the volume of containers, so that you know how much liquid they can carry. Also, the size of a warehouse. All right. Suppose I tell you that I tell you let's go back to the board. Okay. All right. Suppose I tell you that I have a warehouse and it is like it's by 10 by 8 meters. All right, the warehouse. Okay, so now I know that it's 10 by 8. Yeah, that is like 80 square meters. 80 square meters on the ground, on the surface. 80 square meters. All right. So now I'm like, good, 80 square meters, but how high is it? Because when you are dealing with warehouses, you need to know how high you can park your. Imagine if it was like 80 square meters and the height is let's say 5 5 meters high. Okay, you are like, no, I want to stack things longer. I need warehouses that have long ceiling. All right. So here in this case, you see this space here, only the ground doesn't matter. You need to know how high it can go so that you can know how high you can stack your stock. So here volume matters, right? You don't just want to know the area on the surface. Here when we talk about the land, we mention about here you don't want to know about the height, because the height doesn't matter. You haven't built anything here as well. Here also you don't need to know about the height whatever, because there is no height here, because you have the length. Probably the height is, you want to know the height and the length, but the width, there's nothing like, it's two dimension, 2 dimension. But when you are thinking about things like warehouse, things like a container. All right. So for us, for example, when we buy stuff from China, we order them from China, and they charge us per cubic meter. All right. For every cubic meter, they charge us $250. So that's what they charge us. Okay. The Sarahule people, that's what they charge us. Okay. So this is the shipping container. All right. So the shipping container, I think the 20-feet shipping container is around, like, I don't know, I forget how many square meters it is. Cubic meters. It is in cubic meters. All right. So for they charge us per cubic meter. Okay, let's say for every cubic meter, every space it occupies here, this is probably 1 cubic meter. They charge us $250. All right. So imagine if you fit like this cubic meters. Okay, this is what they are going to charge, and other people are going to fit this container like this. So you want to know the volume of this thing, so that you can know what volume of space your entire bagage took. Let's say we only order this tissue paper box inside the container. Now they are going to take what space, the entire space, not only the surface area, but also the height as well, and everything. That's where volume really matters. They want to know what volume of space your container or whatever you have occupies in that stuff. Okay, let's say inside the container, like this bag, what is the space they occupy? This cartons here. All right. So it's very important. Here, situation where it's important to know the volume includes the amount of water a bottle or tank can carry, and the space in shipping containers, and the boot of a car. Inside your boot also, you want to know the space. All right, the entire space, not just the surface area. That's where height come in. All right. You may also want to know the height of floor ceiling of to determine, the volume or carrying capacity of a warehouse. This one we have already talked about this. All right. So these are the applications of area, length, and volume. All right. So one thing I also want to know is to know. I know every day you hear about this word 3D, 3D this, 2D this. So what is 1D? 1D you are only referring to one length, one side here only. All right. This is we talk about length. As you see, length or distance. One dimension. This is a curve. All right. So 2 dimension is flat. Only one side of something. One side of something. Maybe it's on this is a parcel of land or whatever, or this is the side of this thing, one side of something. All right, that means the 2 dimension. All right, one side of something, that means that you're only calculating length. Let's say this is the height. Okay, this is the length. All right, this is the length, and you multiply them and you get this area. This is only facing you. You don't see the back side, you don't see the downside. Okay, or when you want to calculate the area of this thing, 2 dimension. All right, you only take 2 dimension, the height and the width here and the length here. You see, so this is 2 dimension. A triangle is a 2 dimension. All right. 2 dimension also means when you print something on a piece of paper. All right, when you print something here, it means that you are printing on the flat surface. That's why we call it 2D printing. Like when you print on a piece of paper on a sticker, it's 2D printing. All right, but what happens also when you consider 3 sides? Now you have 3D. That's why 3 dimension. You are considering the width here. Okay, you are considering the length here, the width here, and the height here. Remember, this thing does not have height or width. It only has two sides, two lengths. All right, you can call this height or width, whichever you want, and you can call this length. All right, so this one is called length or height, width, whatever. It has 2 sides. All right, so this is what also this one, it has base and sides. All right, it's flat, but these things, they are 3D. They have different, you see, they have different sides. Okay, length times with cube. Okay, this triangle now becomes a cone. Okay, it now has a height, something like this, whatever. Now it is 2 dimension, 3 dimension. So I'm just telling you, whenever you see 1D, 2D, 3D, know that when you talk about 3D, it talks about volume. 2D talks about area. 1D talks about 1 dimension only, length. All right. All right. So other types of measurement, we talk about that. We measure things like, weight, time, temperature, distance, all this type of measurement we measure. But as I told you, we only focus on what? Length, where we can derive volume, area, and to some extent mass. All right. I did a quick roundup on the terms. You can read them. What is an object? An object is a physical item or space. All right. Length. What is length? The distance between 2 points. Okay. Length can also mean the longest side of an object. We talk about width. Width, also called breadth, is the shorter side of an object. Height or tallness or thickness of an object. A curve. A parallelogram. These are, like a square is a parallelogram because 2 sides are equal, or a rectangle. What is adjacent? We talk about what is adjacent. When somebody tell you what is adjacent, you should know what is adjacent. All right, because I think I should make this point clear here. Okay, there's this difference between adjacent and opposite. All right, when you have this box here, this side and this side, they are opposite. All right, this side and this side, they are opposite. Adjacent means they are close together. They are closer by. They are closer by. Opposite, this side and this side, they are opposite. Adjacent means they touch each other somehow. Let's say this is the road. All right, this is the road. All right, let's say these are houses here, or shops, whatever you call them, and these are houses or shops, whatever you call them. These places are adjacent to each other. That's the English word adjacent. Opposite means what? This opposite to this. Oh, they are opposite, 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 adjacent, 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 adjacent. All right, so it's very important. When you hear the term opposite or adjacent, this is what they mean. We talk about diameter, what diameter means, radius. We talk about circumference. We talk about 1 dimension, 2 dimension, 3 dimension. Okay, like nowadays, many people, what they do is they do 3D printing. All right, 3D printing, like when you have a signboard, you don't put it on a flat signboard like that. People now put their names in 3D format, wherein it has a thickness, it comes out a little bit. Now it is a whole 3D dimension. Right? We talk about area, we talk about volume, we talk about mass. We didn't talk about mass that much, but mass measures how heavy something is. Mass measure how heavy something is. All right. So units of measurement. All right. So the denomination or names given to the quantity of things is like for example meters. When you talk about meters, it means the length of something. Like we talk about liters, ounces, dollars. What those dollars measure? The Gambian money, of course. Dollars, tons. All right. All these things are units of measurement. All right. And these units of measurement have symbols. Like for M is for meters, L is for liters, D or GMD is for dollars. FT is for foot, and you have dollar, the dollar sign for the dollar. All right. So these are like the units of measurement, like kilogram, like candela, Kelvin, blah blah blah. All right. So just a final quick summary here. It says that what do they measure? These things. Length. It measures how long something is. How long something is. Area. What is area? How big something is on the surface. How big something is on the surface or on one side. All right. Volume, how big something is entirely how big something is entirely. Mass, how heavy something is.